Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
Hey, I'm John.
And this week we're going to kind of talk about, rapid prototyping. And the thing is that kind of stretches across everything we've talked about, up to this day. It's all your IT stuff, your tech stuff, to your additive manufacturing environments and stuff like that, to your OT standpoint of how you're having to rapid prototype stations, locations, technologies, stuff like that. If you think about it, we got the, FDM printers, Senator printers, and all the other fun crap, that we use to rapid prototype parts. However, at that same point in time, we're having to rapid prototype websites, servers, that type of stuff, using Docker containers, using WYSIWYGs, what you see is what you get. We're using extruded aluminum out there to prototype stations and controls technologies just to make sure that things will run, So it's like when you talk about rapid prototyping, we're not really talking about a small scale application. We're looking at rapid prototyping as a conglomerate whole. Rapid prototyping crosses the industry, not just in manufacturing where, usually when we're talking about technologies, that's kind of where we like to stay, but it crosses all domain spaces, from the cybersecurity namespace all the way up into the manufacturing namespace and then on to the development namespace, depending on, where you're at and everywhere in between. So, I'm going to turn it over to y'all. Whoever wants to take it, be my guest. What do y'all think about, rapid prototyping? Because, right now, as model years come out, stuff comes out, all that, we're dealing with a rapid prototyping situation.
Yeah. I kind of want to, I'll start and then I'll hand it off to you, Ed. But, so the first thing I'm thinking of when we're talking like rapid prototyping, it is that you can try some things that you probably couldn't afford to do on a full scale, right? Of course, we were thinking, like, you don't want small items. Like, I'm not just trying to print this one little clip here. I want to print the whole piece and see how things work together. And is my idea physically sound? Will these parts, I don't know, you tend to start seeing some things when you let's say print it, and it's just a model. You tend to see some things that you wouldn't have seen before, and you start to notice some things, and then you can kind of adjust your prototype without having to fully make another car.
How would you rapid prototype come up to that point?
So you mean the car up to that point?
The thing is, if you think about it, everything is a whole at that point.
Yeah. So you can do
multi-layer.
What's that?
Multi-layer.
So you can do different, of course, multi-layers. You can print the parts as well separately and see if they attach all together, and then you have the whole picture. And then I was also going to say, like, on a process side, is like if you have a whole new process you need to introduce for your new product, and you don't have necessarily the tools or the connections to do so. You can kind of make those things and see if your idea would work before buying a whole set of robots to do something, right? You can have it run with a couple pieces you printed and on a small scale, and then we've talked about it before, simplicity scales. So if you can get your process there to work, and then it can formulate your end goal, because I'm thinking about 3D printing as a means to an end, not it's the piece. So if you're thinking about it, how do I make this process better with 3D printing? That's where I would start with the rapid prototyping, and then eventually it'd be nice to have a model of what the end goal would be.
So all prototyping has to begin with CAM. You can't even print anything without a model.
Yeah.
So everything is going to be modeled and everything is going to be simulated. So all that's going to be simulated with software first. Now, somebody may sketch something on a piece of paper, but that sketch will be turned into a three-dimensional device. So that's step one.
Yeah.
Step two is going to be the person saying, "Hey, that's what I like. I think that's a good idea, but I don't want to spend $100,000 sending this to a fabricator or to a machinist to machine this out." Yeah. This is where the 3D printer comes in. The 3D printer is the thing if I need to take an idea from my head and test it out without spending thousands of dollars, that I can make a prototype or a model that I can look at without having to spend thousands of hours trying to build this thing by myself. Right. That's the thing that the 3D printer. So what we're getting into then after that is, okay, yeah, I have that. And of course, mathematics and all those things will be put into place first, because you have to look at stress of things, the material. You have to look at how would it be affected by the environment. If I have something that has to have a human inside of it, how would this thing be affected by forces? If it's hit from the side, from the front, from the top. What about elemental things like rust, rain, sun, UV, so forth. So those things will be done pre. Right. But far as if I want something in my hand to be able to touch it, to say, hey, this looks right, or even if I want my marketing department to be able to have something, hey, do you like this? Does it look good? Did we do a survey and see what people were asking for? Is this ergonomic for every body style? Is this safe? Because now I can take that model and say, hey, this looks safe, but then I can kind of do some experiments. So that's, to me, that's the soul of a 3D printer.
Now, how would you support because I know how I would support it, but how would you support the rapid prototyping aspect of any industry from the OT standpoint?
Well, I think like when we're talking rapid prototyping,
you're also talking rapid station design too.
Either way, everything starts with a simulation. Like no one says, "Hey, go get a piece of foam and start cutting stuff." That's only in special effects and things like Star Wars. But when I'm on a factory floor, even when we start using extruded aluminum, that is only used for, hey, this is for a moderate application. If I need to put pillars to hold the building up, I'm going to have a structural engineer do calculations first.
Short term versus long term.
Step one is someone has to take that education that they got from whatever university, 4-year or master degree or whatever they got, and then be able to take that and apply it with physics and those things first. Yeah. Then to the question you're asking, from my side, how does that apply to me? It applies to me because on the machine side, can the machine do what the engineer wants it to do? Yep. But what is the maintenance to that machine?
Because you have to prototype out the station the systematic response prior to buying the equipment.
Well, sometimes we have to take some bad with the good.
Right, exactly. But the thing is then you're starting to deal with the old thing of cardboard stations. Where I build a cardboard station out and I walk through it, I kind of see what my equipment wants to do and stuff like that. And then it's kind of like a WYSIWYG. First station before you actually go out and put the purchase order out for it and the PR and all the other crap. You actually start building that station one piece at a time. You're going to get what you want. And the good thing is like we're doing a couple projects now, but as we get ready to order equipment, we start rapid prototyping that equipment and saying, okay, cool. How am I to support that? What does my support process look like?
So that's when you take your engineers and your maintenance personnel and they go buy off the equipment. Because the engineers, like I said, engineers live in a mathematical world. And the engineers live in a mathematical world. Hey, it worked for me once, sign it off. Whereas maintenance and the engineers that are on the floor live in a different world. So process engineers and maintenance engineers live in a different world. That's because machinery works a certain way for a certain amount of time. But what happens when the humans... Well, I'm saying humans interact with it. Yeah, right. Maybe the humans did something that we didn't. When we do those models with software is a lot more robust because we do a lot more testing. Right. With hardware, we don't do the same amount of testing. We take parts and put them together from suppliers, and the suppliers say, hey, this is what we've done in the past. this is new, we'll use this is better, it's more efficient.
Well, what about like offline station setup?
Even offline, it's the same thing, because what happens with builders use certain building blocks.
Yeah.
They don't, I'm going out to use the newest thing. They're going to use what's, to put it this way, they're going to use things that they know work.
Right. Now,
and maybe that doesn't work for every application when you're dealing with humans operating this equipment.
it's like, from my side, for example, and I'm going to jump on, put the IT and ID hat on for a little bit and kind of play in that realm. When we're trying to rapid prototype something and stuff like that, we're looking at like a WYSIWYG. What you see is what you get. We're going to build your application real quick, see what you like. If you like it, kind of like a terrain model. If you're talking about like, military field applications, a terrain model. It's what it is before you get to the target location, before you get what you want. However, if you're talking about like something called Blue Griffin, Blue Griffin's a WYSIWYG. It helps you build that application, that website mainframe before you actually see it. So you see exactly what you want, the buttons work, everything kind of changes stations and stuff like that, and how you go. We want to start at plan A and work our way back. I can build an entire application just on my laptop, be able to test it all the way out before I put the PO and PR process out. I know what I want it to do. Mm-hmm. I know how I'm requesting that. When from my side, when I'm supporting a, maintenance installation or production installation or engineering installation, we kind of look at it, from the outside looking in. Because we're also looking at it from the, okay, cool, how is my system going to support this? So let me start prototyping system interfaces, system applications to work with this equipment. Because it might be new. It's like you start talking about, additive manufacturing and stuff like that, and you start dealing with the fact that now I have to secure the damn thing. Mm-hmm. Also, you're dealing with building applications for it, SaaS products for it. Also, there's all these other products for an industry that's really not fully built up yet. However, it's getting there. I see within the next probably 5 to 10 years, it's booming. Right now in the consumer namespace, it's what, multi-million dollars? Toward $1 trillion at this point, and growing drastically by the day. Yep. And the thing is we see more and more rapid prototyping companies pop up, here and there, that are leveraging the additive manufacturing namespace, and also deductive manufacturing, like CNC and stuff like that, injection molding and whatnot, but the thing is, it's always, you have to have a system to support that. If you don't have a system to support it, you ain't getting anywhere. Right. And what I was getting at for offline station modification is bringing the entire station that you're going to install inline offline, bring it into the location, let the team members work on it, and kind of see what happens. You're rapidly prototyping that station without actually putting that station in full-blown production yet.
Mm-hmm. That's it.
We've done that on multiple occasions. Yeah. And the thing is right there, from the IT standpoint, from the maintenance standpoint, the engineering standpoint, we found issues almost immediately. But the thing is what that took us from, okay, cool, I've done my my walkthrough with the cardboard boxes. I've used my AR to adjust, where I want things. And then I went to the shop floor where I don't have a 6'3" engineer. I got a 5'2", little short thing, freaking, working on a line that can't reach anything. Guess what? I got to move things down. Yeah. I'm prototyping at this point. Now, when I go to actually put that station in production, I know all I got to do is copy paste, right, until it's there. You put in the equipment all day long, day in, day out. And sometimes you run into issues, and from like our standpoint, from the IT standpoint, especially when I'm dealing with like MQTT and stuff like that, Industry 4.0, when I'm dealing inside that namespace, it's nothing but rapid prototyping, because the thing is Industry 4.0 is brand new. It's something that hasn't been around for decades, so it hasn't been fully formulated yet. So, your guys who are leading the charge are pioneering this stuff. But the thing is you can still take that IoT and the IoT standpoint and port it to additive manufacturing. We really felt like it easily. It's the thing is, if you think about it, we have companies out there 3D printing rockets, using IoT, and using KUKA robots with weld heads on them to build things that are going to fly. Let that sink in for a minute. So
that'll land.
It'll land,
and you could fly it again.
Right, exactly.
So here's the argument again. You can never make software match hardware.
No,
you can never make the physical world match virtual world. So what I'm telling you is in an industrial environment that a company has millions of dollars, you're right. In space where somebody has billions of dollars, you're right. Even in military where somebody has billions of dollars, you're right. But where we stand today at a hobbyist level with a 3D printer, it is not at the same level as making a rocket.
Right.
That rocket that you're talking about is using sophisticated stuff that is not just something that I can take off the shelf. Even robot integrators can't even do that. They had to make special software to make that robot work. They had to make special hardware, and they even had to probably adjust the filament to work for that.
Yeah.
So what you're saying is totally correct. Far as we're talking about where space and science.
But that's just ideas of how it's working.
No. We know that space is working. We know that somebody printed a rocket. It went in space. It came back. That is not something that we're saying that we think works. We know it works. We know that the military has used applications, and we know it works. We know that even major car manufacturers have used this, and even the airlines have used this, and it works. Mm-hmm. My argument is that, yes, we can do 90% of this stuff virtual, but do you know that most of it, and you can ask any robot programmer anywhere, it's about 60% accurate.
Yeah, exactly.
Because they have to still go out in the field.
Yeah, nothing's going to take out the mechanical
trial and
input.
But we're talking about a factory. We're not talking about building one object over and over.
Right, exactly.
We're just talking a factory.
Exactly.
We're saying a factory level.
Yeah.
So
I agree with that.
I think you're correct in what you're saying that in 5 years we'll be there, because we won't be relying on humans.
Right.
We'll have AI, machine learning, IoT giving data back. We'll have the things.
We'll have the feedback circle set up
to make us get to that point.
Well, see, that's the thing is the feedback loop that like it'll continuously upgrade. I think kind of getting back to what you were talking about earlier, Nick, when you were saying like the world revolves around money. I mean, it is what it is.
Yeah.
So when I'm thinking rapid prototyping, it's how do I get this? How can I prove that this will work, and then get the funding for it? Because if I just came to you with the idea, you're gonna tell me I'm crazy.
Yeah.
So for me, it's building a business case. So if I've got something that I'm like, hey, I know this sounds crazy, but hear me out. I'm gonna replace the heat bed with a kettle or with a griddle, and we're gonna replace the hot end with a syringe that outputs pancake batter. It'll use the same geometry code, the G code,
and
right? So it'll work, right?
Yeah.
But if you came to me and told me that when I just found out about 3D printing, I'm going to say that you're crazy. I was like, you can't even get this right. Why are you trying to do it like that?
I'd tell you to print a pyramid.
Yeah, show me the print works. So the rapid prototyping, maybe on a whole process of a whole printer level, is not going to work like that. But like if I came to you with an outlandish idea, like, and I was like, hey, by the way, this will work. Watch. And then show you with the parts that's been 3D printed and kind of formulated that side. That's what we're talking about with the CNC and making like carts or something like that. That's like limited lifetime. We don't even know if this process is going to be here next week. We moved this process over here because we thought it would be better, but then which by the way costs a lot of money to do, and then we start doing it and realize this is terrible. It's costing us more money. We need to move it back. So you're now twice in the hole, and you done lost all the money when you were trying to produce in that other section. So it's like saving that time and headache for not only the engineer, the OT guy, and the IT guy. It's I think that the merit and the value in just getting it to that point and then justifying the budget cost, it's also going to bring costs down. Like as overall, like you might even realize that, hey, I was gonna buy these parts metal. The 3D parts work better. They slide better. Things like that. The weight taken off of it may make this glide a little bit better and things like that. So it's a lot of course trial and error. We're doing the scientific method with this. Like it's never gonna be perfect, I'd say. There's always going to be something that you can upgrade.
And well, the thing is, it also helps you prototype out your CAD CAM information. Yeah. Is the CAD CAM information correct before I put a mass order in for this?
Oh yeah.
And have this produced. I can print out something that's 4 or 5 cents. You know, bring it to the line, validate. Okay, cool. My clips work. Cool. Now let me put an order in. My geometry doesn't suck. You know, but if you go out there and you're like, oh crap, I'm 2 millimeters off. Whoops. You know, let me go back and redo this again. You know, you're only what 8 cents, if you count your time and the energy that you used. I couldn't tell you how many times, and Ed's over here grinning like an eager beaver. You know, because the amount of times that we've seen people waste money on parts and say it'll fit, and he ordered 100 parts of it. You're like,
coming back next week, got to
that don't
scrap
fit.
his parts.
Like I said,
I want to talk about it.
that is the use case for 3D printers. The use
think
case
that's
for
the best
3D
case.
printers
Yeah.
is I can do rapid prototyping. I can take it out into the physical environment and install it, or I can take it and be able to hold it in my hands. Because there are some shapes that I don't care what technology we have, they cannot make them.
No.
It is feasibly impossible only by 3D printing or by using resin or some technology with we use some powder and we fuse the powder. Only with those technologies can you even make these shapes.
Right.
So just for me, and I am a proponent of 3D printing. I just know, far as the hobbyist compared to where we are with industrial and things like that, is not the same.
Yeah.
Even in the application when we say in manufacturing, when this becomes a viable thing, is the weakest point, or the thing that I think is the limiter or the governor in this system is the filament or the materials.
Right.
The materials just have not been able to be made economical enough, or they have not found the right composition with these materials, that this material here has the same strength as titanium. Yes, it's close, but it's not titanium.
And I think that's
You
where
can
we need to
ask
have the
Yeah.
because they're titanium tantalum or something
Yeah.
like
Yeah,
that.
they print it, but
Yeah.
if Singapore has it, why is it not in every
you know,
market?
but it's like the thing is, it's like,
It's in select things.
and I think that, you know, that's where we kind of turn to the industry, and you know, and they need to get involved and kind of, you know, support, you know, something that's going on. You know, it'll never replace traditional manufacturing methods.
I think you're wrong. I think it will.
Maybe eventually, yeah.
I think it will.
It's just, you know, with enough support from the industry, it could catch up, and it's getting there. You know, but the thing is the ability to take something from the CAD CAM namespace to the physical hardware namespace makes a difference. Because, you know, I don't want an engineer developing a hammer that's an octagon, and you hand it to me, it's like, what the hell is this?
I bet you gave it back to him and tell him to try it. He wouldn't know where to start.
Right, exactly. So it's like, you know,
and
at
in
least give
real
you something to
time-
hold on to.
In real time, you can do that. You can do that evaluation in real time.
Yeah.
I don't have to wait 6 weeks for something to be manufactured.
Right.
I can get it in 60 minutes,
Right.
So in that sense, it's saving time.
Yeah.
So it's saving
which is
headache.
what?
And saving money.
Money, yeah. Time is money.
Money is time, you know, time is money. You know, and it's the whole thing of, you know, slow is fast, fast is slow. You know, it just kind of really just depends on where you're going with it.
Now I will agree that on the filament and material side, like those consumables, they've got some way to go. You know, if you're thinking about what's the most easily produced, you know, or mass produced right now, PLA, that's consumer level. That's not gonna be impact resistant, heat resistant. It's none of those things. You could take heat to it again; it'll melt back to like a little a puddle of plastic on your print bed. So in that sense, yeah, I can say that it's got a ways to go. I agree, Nick, that industry needs to kind of get a buy-in, and that's not the easiest thing in the world to do, because you've got to convince everybody. And you know, when you're leading projects like that, you've got to convince not only the manager who's holding the budget in their hand, you got to convince the project leader whose head is on the block if that budget doesn't match or those deadlines don't match.
Right.
But if you can get into their head and you can say, hey, when's your due date? You've got 4 or 5 weeks to do this. Okay, I'll get you 4 or 5 prototypes, or I'll get you a prototype a day for the first week until we find out what we can do, and I'll get you everything after that. I think that they would bite on that immediately.
Exactly.
So like that's, I mean, it needs work, but
So
it's moving in the right direction.
Let me say this. So by no means am I saying that 3D printing is not the next thing that's going to be revolutionary, or the next thing that's coming for manufacturing. I guess what I'm saying is what we just said, what Nick said. Okay, all the things we said about the advantages of it, everybody knows.
Yep.
The biggest advantage is getting it in the consumer's hand. That, to me, that is the biggest advantage of 3D printing. You're being able to take something and put it into an engineering student hand so that he can create things that he probably otherwise wouldn't be able to create without help. Yeah. But the thing about the 3D printer is, this is why I feel maybe it's a little longer than 5 years. But I am telling you, once they perfect the filament, once they perfect the medium, once they make that economical enough where a manufacturer can take that and print stuff as strong as steel, or print stuff as lighter than titanium, or make alloys that you couldn't make any other way, that's going to be the thing that gets you into space. That's going to be the things that gets you past Mars. So this is the technology of the future.
Yeah.
You know, as with me, I always just try to tell what I see now. It's young, but it's growing.
I see it as part of the Industry 4.0 namespace. You know, I definitely see that. You know, I see that we've kind of hit that marker, you know, at the start of the Industrial Revolution, the 4.0. But it's not going to be mainstream probably till the middle to the end of it. You know, we're going to Industry, 4.5 or whatever the Germans come up with next. So even then, they're using it a lot more than we are, you know, at this point. And, you know, the thing is, hey, you know, if that's the case, share the wealth. Yeah. You know, let us know what you're doing. You know, we want to know. You know, it's the thing that, you know, when you look at it, you know, getting somebody, like you said, somebody in school to use it to kind of learn, you know, what metallurgy is and stuff like that, your different your properties and stuff that you're dealing with. But the other thing that I see the greatest part of, you know, with a additive manufacturing, you know, or 3D printer, or however the heck you want to look at it, you know, the best one out there is freeforms right now, is the fact that medical students, medical universities buying one of these things to make parts that the students may not see unless it was printed with a printer. You know,
like what would you use before that? Cadavers, things like
right.
that, and it wouldn't be.
You know, I understand that. You know, we've lost a lot of people in the last couple of years. However, there's not a whole lot of people volunteering to be a cadaver. So the greatest part that you get is the fact that you can get some of these 3D printers printing realistic skulls, bones, stuff like that, that shows these students how to do a splice. You know, shows them how to do certain things. Also, your TPU filament, your flexible filaments, you can learn to stitch wounds up with it. You know, and teach, you know, some of your medical doctors on how to do stitches and butterfly stitches and stuff like that. Cut it out, and guess what? It's back normal again. You know, you have that. You know, you mold that around a 3D printed bone. You know, and you can actually you can go through the entire process. If you think about it, you make 3D printed bones and you make the rest of the organs of that with TPU or TPE. You know,
or resin print.
Or resin
can be done with resin.
Right, and that's where the freeform guys come in.
Yeah.
The freeform, and I'll bring them back up. You know, Freeform Industries, those guys who are building the freeform printers, they did a great job from all the stuff I've seen. You know, stuff like that. You know, their filaments and powders that they, you know, take into account, they're very precise. I mean, they're absolutely micron precise at this point.
Not even just the materials, but like the software that.
Yeah, it's leaps and bounds better than everybody else.
Wow.
Which, let's be honest, the software is always ahead of everything.
Right, exactly.
Because, unfortunately, with software, there's
working IT, and you'll realize that's really a kind of common
well, but
error.
I mean, like, let's be honest, software always have the mechanisms in place to verify.
Right.
To a point. Whereas the hardware is, we have a firmware, and it's locked into that firmware, and then the manufacturer is saying, you know, he uses this firmware and don't want to update it. That's why you have some of the exploits because of that. Yeah. But software as a general, like even when you're talking IT and you're talking, hey, I'm doing web development or a SaaS product, or even if you're just doing a web-based application, it's a lot of testing that going in there.
Yeah.
Nobody just spit out a little bit of code and say, hey, it's perfect. Somebody has to vet that. It's a little bit different in the hardware side.
Yeah. Mind you, we've had those people that say, "Hey, I built this. This works now," and they spit it out, and you go, "It don't work.
Yeah, nope.
Yeah, don't try that again, please. Nope. This doesn't work this way."
And that's why the software part of anything right now is because how do you think GitHub was born?
Yeah.
How do you think open source was born? It was by people saying that they're going to share, and that's what's going to happen with 3D printing. You got open source.
Yeah.
You got people, sharing projects, sharing models.
Thingiverse.
And the reason that the filament is even where it is now is because of hobbyists.
Yep.
Yeah.
The hobbyists are the one that's trying all these different filaments.
Well, and the thing is that that kind of leads you to the fact that your next generation engineers have been exposed to this for longer than most of us have ever thought about. You got guys or kids right now that are 10, 11 years old who have been playing with 3D printers for the past 5 or 6 years. They're going to grow up in a world of 3D printers. Right now we have engineers who only fathom that these things were around when they were in school, and they were doing what I was doing when I was in middle school and building bridges out of sticks and things.
Yep. And volcanoes,
right?
Paper mache. Well,
now you got a 3D printer that you just print the darn thing out and stick a thing in the bottom of it. All good.
I want to throw something to John. What would a physicist that was young would have been able to do with a 3D printer?
Oh man, there was a lot of things that I did when I was in high school that I had to make something, do something it was not supposed to. I think that my favorite class actually that I remember was honors geometry, and we were just thinking about how shapes fit and things like that. And if I was given a 3D printer in that mindset, we were doing projects like how can you create something to absorb impact when dropped at 5 feet, 10 feet, 15 feet off the top of the bleachers. If I could,
egg test.
Yeah, it was the egg test. So if I could, and I had to make that out of household things. I couldn't take anything else out. But if she said make it with every part with a 3D printer, I bet you there'd be a lot crazier items that would come out of there. That's my first thing that I think of immediately, because we also made kites and things like that, and I was making kites out of what was it, bottles and newspaper and straws and stuff like that. If you give me a 3D printer, I'd make a crazy looking kite. So that's one thing. If you taught me how to work with CAD, anything, you'd have some crazy items. And if we get that, that's what I was gonna actually go to when I was gonna give you guys time to finish. But the teaching aspect of it is, I think, just invaluable, because you're saying, we talked about it a second ago, is the engineer whose mind is math and isn't thinking of the hardware or the application side of it. He's like, on paper, this is good. I've tested, I've ran the numbers, this will work. And then you give it to the OT guy, and he's like, it ain't gonna work. It don't work. He's like, okay, well, you reach that up there, and I'll sit down here because I'm only 4 foot tall. You go ahead and do that piece. That will teach that engineer physically, this is not feasible. Things like that. And then also it gets into the point where the feedback loop is, you teach that engineer may find something that he likes, start showing it to people, kind of how we've been honestly doing.
Yeah.
It's growing it in that sense. So for me, the geometry class is the first thing I think of. Now on the calculus side, rates of change and things like that, I can immediately think of applications of that. If I stepped up into even on my college courses with gradients and changes like that, fluxes and things like that, how does charge go through this material? That would have changed all of my classes, period. So I don't know. Now you're gonna make me go look up some of my old notebooks and start seeing what I was working on.
But the thing is that this goes back to the conversation that we've had, in the past. It's there needs to be a need to get I know we're running over, that to get a 3D printer of some sort into the hands of teachers. Yeah. We need to make that change, and we need to make that change quickly. If we know that the 3D printers are being pushed into the the fourth industrial revolution, this current revolution, the industry 5.0, which will be following, in a couple of years after this. We know that's coming. We know additive manufacturing is on the way. We know it's not going to stop. We need to make the conservative approach is to get, these systems into the hands of kids, teachers, professors, parents, to show kids that, anything's possible. Yeah. It's cool. We use them at work, whatnot. Print our prototyping parts. However, a kid taking it and taking theory and making it, a hard, proof out of it, is, mind blowing. Because that's something they get to live with now.
Yeah. And I tell you what, it would stick with me, like, forever. Because I still remember the shape that I made for my egg drop. I still remember what I used and how I got it to work. I didn't win, by the way. It was a competition.
But if you think about it, if you get these into the classrooms now, you'll have more prepared engineers,
100%.
getting through, more prepared physicists getting through the systems now. More people who
100%.
understand, more prepared maintenance techs who are coming, or maintenance engineers who are coming through the standpoint of, hey, guess what? This is what this means physically.
Yeah.
I know how it, how this bolt works and how it was formed and stuff like that.
Mm-hmm.
I know what sintering technology is. I know what, using, flux welding is to, prevent to create something. Mm-hmm. However, that's on a bigger scale, and please don't put that in the classroom. That might end up very badly. So, we start getting into, like, spin welding and all that other, we'll leave that one out for now. Stir welding.
I'm actually curious.
I would say we would, but I don't have, $2 million to buy a stir welder.
I know a guy. We'll call him maybe, and I'll say, hey, let me just use it one time.
Like I said, that's probably, for me, that was probably I would say 8 to 10 years ago where we saw that technology first being used in a lab. But
now it's normal.
Now it's normal. Replacing pieces.
But in the future, that may not even be necessary. If the filaments can come up, and they can, I imagine that some of these exotic filaments exist, and in some patents, or exist in a military application, or in some science or space application that's not feasible for, say, on a consumer level, or feasible for a manufacturing process because of cycle times. Mm-hmm. But I imagine that maybe what we think 3D printing is becomes something different in the future.
I 100% agree.
Yeah. Maybe we're using wavelengths to do, or microwave energy, or some other type of energy other than heat.
Well, think about, taking mag welding, or MIG welding. Yeah. As you add a layer on top of layer on top of layer, technically you're 3D printing.
Well, see, that's exactly the point I was going to get to. Is like, it's the chemical process is what actually is like. So I'm 3D printing something. Okay, so you're making something, but it's how. My chemical process of just, applying heat works for the FDM. Yeah. Applying UV rays works for resins. Yeah. Powder bed welding. You're physically welding that powder with the laser in those positions. So, like, it's the chemical reaction. Like, maybe there's probably chemical reactions we haven't touched on that could assist in 3D printing as well.
That's when you start getting like the argon and then that you start getting into different types of chemical additives. Right.
But in a microwave right now, I can do things in microwave and accelerate molecules in any material. Yeah.
Mm-hmm. Water is a good way to look at that.
Well, let's say that there are molecules in plastic, or molecules in whatever material you want to use. Even metal has molecules.
Oh yeah.
If you're able to generate enough energy that you can manipulate those molecules, whether I use electricity, high voltage electricity, UV with resin, heat, or I change the voltage from a negative to a positive, or I use nuclear reaction, or I just use a chemical reaction, whatever it is. What I'm getting at is that technology has just not been taken from a application where it's billions or millions of dollars to an application where it becomes a few $1,000s.
Right.
When that application becomes a few $1,000s, that's why companies laser weld right now.
Yeah.
Yeah, it's true. It's true.
So I mean, it's just a matter of making things that already exist. So the science is there.
Yep.
It just has to be scaled down
The application
to manufacturing.
Yeah.
That's the only difference.
Scale down or scale up, depending on how you look at it.
Yeah.
Well, scale down and then scale up the
Right.
technology that you're trying to apply to.
If you can make it on a
manufacturing.
simple scale first, I think that's probably just the most preferable.
And if you think about it, the guys who are leading the packs on industrial 3D printers right now, is HP, Canon, the
You'd be
big.
surprised. Siemens may not have a printer itself. Well, they might have a printer.
But they got the software to do it.
They do the software.
They got the software, yeah. So they and I'd be surprised. I wouldn't be surprised if they have the actual ones that can, make it. From
Well,
there.
the thing is, it's like when he say HP and Canon, it's a reason he said HP and Canon.
Oh yeah.
The reason we have laser, inkjet printers and laser printers.
HP led the pack on that.
They developed that technology like 50 years ago.
Now they have laser
So
3D printers.
I wonder what are Polaroids at.
So I'm just saying, like,
Yeah.
It's still around.
Yeah.
but I'm saying, like, they developed that
Yeah,
technology, and
right.
these guys got like years of experience. But it's not going to be one company that's going to do it. It's going to be everybody. It's just like with welding.
Yeah.
Like, I don't care if you use ABB or you use Fanuc or whatever, Moto Man or whatever robot you use. It doesn't matter. The concept is the same. You have a something that's getting you voltage, and that voltage is being applied. You have a filament, which is welding wire, and you have a gas, which is causing the chemical reaction, or a blanket
Yeah, shielding gas.
basically. And that's that chemical reaction you're talking about.
Yeah.
That's the process of the filament that's at the point that it's been developed. And we're talking about welding wire that goes crazy.
Yeah.
There's so many different type of welding wires.
Yeah, solid
It's
to
insane.
liquid to solid, yeah.
Yeah, so what I'm saying is
To a gas.
And the
technically.
gauge too.
the
probably
concept is
thicker.
there.
Yeah.
We just have to make this that's at the hobbyist level, which the hobbyists are probably the ones who are going to figure out the way to apply it to a manufacturing process. And then the people that's in the industry are going to figure out a way to make the medium work affordably.
Yep. I can see that. And I think really, we can talk about rapid prototyping all night.
Yeah, probably.
And so this is probably not going to be our only episode of rapid prototyping. We're probably going to get down a little bit deeper into some of the namespaces, that we kind of discussed. But, again, I want to throw out there, I want to say, thank you, to everybody who's taking the time out of their day, to listen to, the ramble and the, slight sarcasm that we got going on.
Slight.
Yeah. I like cutting things short, but
There we go.
you should know that. Hello phone book.
Right.
So learn we don't take each other serious. We're too serious at least, especially not yet. But at least we have fun with it. That's what matters. We hope you all have fun with it too. Send us questions, concerns, comments. But we'll go from there. We'll see where that goes. But it's one of those things of thank you. We never thought that we would ever get to this point. When me and Ed started this adventure, we were just happy it made it to Georgia.
We got
And it's grown a little bit past the U.S. and we've now migrated to different parts of the world. Parts that some of us never been to, parts of us won't want to go to. We'll see how that goes.
Okay.
But from me, I say thank you. I'm gonna turn over to the guys. Have a good night, and we'll catch you around.
So if you can't question each other, or if you can't challenge each other, you're never going to get to what's beneath. If everybody agrees, then nobody ever gets to, why can't we do that? Well, it's always been that way. Well, it don't have to always be that way. So everybody has a different vantage point because everybody's not the same height. I mean, some people are taller, Some people are shorter.
Why we keep going back to this?
So you step off that stool, you won't be sitting on the table.
But I will say this, and I know we're going over a little bit, but the thing I will say is that we do this because we're passionate about it.
Yeah.
We're not grandstanding or trying to get attention from people. We're trying to bring awareness to people. We might have always started the same direction, but we always end up at the same point. Yeah. So, like I said, I appreciate all of the support, and we're gonna turn it over to Chance, and thank you guys.
Yeah, I mean, I echo the same thing always. Thank you. To Ed's point, it's those people that are telling you no, or giving you reasons, detractors, whatever you want to call it, they are also a means to get you to improve. So it's not, it shouldn't ever be a negative. So honestly, from us, if you hear something that you don't like or you think you particularly disagree with, let's talk about it. I'd like to hear, maybe I haven't seen it from that view, and that's 110% okay. It's okay. Everybody has an opinion. Some people may have a more right opinion than others,
or think they do.
Yeah,
that's true. But no, it's all in good. It's all in good faith, and for us, it's something that if you're not challenging the boundaries, you're not challenging of what people think they know or what people are claiming is 100% the truth, then are you really challenging anything? Are you really trying to improve or innovate? No. So we welcome the challenges. I honestly, I don't mind the discussions. So I welcome you guys. Let us know what you're thinking. If you think that we should try something, if you don't agree with a thought or a process or idea, let us know. I mean, the only thing we could do is talk about it. We could see your side. We may agree with you, but we've never seen it.
Yep.
So, yeah, that's pretty much all I had, though, guys. So we appreciate it.
We'll see y'all later.
Bye.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.